Okay, so lecture 7, moving standard graphs around. So what we want to do here is define what our standard graphs are, and then we want to be able to do two problems. If you're given a formula, can you draw the graph? And if you're given the graph, can you figure out the formula? So what are our three basic graphs that we're going to introduce here? This graph is the absolute value graph, y equals absolute value of x, domain all x, which you can write in interval notation like that, range, well, there's a bottom point to the graph, so it's y greater than or equal to 0, or you could write it as 0, oops, square bracket, 0, infinity in interval notation. And there are three special points that we want to keep track of. This one, which we'll call A, this one, which we'll call B, and this one, which we'll call C. So A is -1, 1. B is the vertex, it's the point at the bottom, 0, 0, and then C is 1, 1. So those are 3 points that are on the graph. A very similar graph is y equals x squared. Looks pretty much the same, except it's curved instead of an angle at the bottom. So its domain is all x, or in interval notation, -infinity to infinity. Range, y greater than or equal to 0, which we can write like that. And it's got the same three special points that the absolute value graph has, -1, 1, 0, 0, and C is 1, 1. And finally, the third graph we want to define here, this is the graph of y equals square root of x. Domain, only positive numbers. So x greater than or equal to 0, or 0, infinity. So the domain starts here and goes to the right, but there's no left side of the graph. The range, well, range starts here, that's the bottom of the graph, and goes up. So y greater than or equal to 0, or 0, infinity. Unlike the other two graphs, this one has a restricted domain. And it's only got two special points that we're particularly interested in. A is the point 0, 0, and B is the point 1, 1. Okay, so those are three basic graphs. And we've got these special points that can help us figuring out how graphs move around. So here's a formula, y equals -x minus 2 quantity squared plus 4. So we want to draw the graph of this. First thing we need is, what is the standard function that we're dealing with? Is it absolute value squaring or square root? That's y equals x squared, right? It's a squaring function, you can tell because it's got a square in it. So how is the graph moved? Well, we started with this equation, and then we changed it to that. We've got a -2 inside. That means we move the graph right 2 units. We've got a minus outside. That means flip over x-axis because it's outside, so it's going to flip it vertically. And then a +4 outside. That means move up 4 units. Great. So how do we sketch the graph of this? Well, we're going to start with our graph of y equals x squared. So there's our basic graph, y equals x squared. It's got 3 special points, A, B, and C. And what we want to do is what happens to those 3 points given these kinds of movements. So A starts at -1, 1, moving it right 2 units. That means we want to add 2 to the x coordinate. So that makes that 1, 1. Minus sign, that's flipping over the x-axis. It's outside of the function. It's outside of these parentheses. So that means that that's going to affect the y coordinate. So 1, -1. And then finally, we move it up 4 units. And then it'll take me to 1, 3. So this is 1, 2, 3. 1, 2, 3, 4. So our new A prime is here at 1, 3. What about B? B is 0, 0. Move it right 2 units means it moves to 2, 0. Flipping over the x-axis means multiply the y coordinate by -1, but multiplying 0 by -1 just gives you 0, and then you move up 4 units. So B is going to end up at 2, 4, which is up 1, 2, shoot, that's wrong. A prime should be up here, and then B prime is up here. And then where does C go? C starts at 1, 1. Right 2 units means adding 2 to the x coordinate. Flipping means multiplying the y coordinate by -1, and then adding 4 means add 4 to the y coordinate. So 3, 3. So that'll move to that point. And so that's the 3 special points of our new parabola. And so we just draw in the parabola going through those 3 points, and you get something that looks like that. All right, so if you keep track of where those 3 points go, you can figure out where the graph is. So here is our formula. Which of our standard function is it? Well, it's the absolute value function, as you can tell by the absolute value signs. Inside the absolute value signs, we subtracted 5, we added 5, and adding 5 means that we're moving to the left 5 units. And then multiplying by -1/2 outside of the absolute value signs means that we're going to, the minus sign will flip it over the x-axis, right, a vertical flip, and then shrink it towards the x-axis by 1/2. Right? So inside moves you left or right, outside moves you vertically. So we'll start. Actually, if we're moving left 5, I shouldn't have put my y-axis there, but that's okay. With a graph of our absolute value function, looks like that. A, B, C are my 3 special points. So A starts at -1, 1. Left 5, we'll move it to -6, 1. Flipping over the x-axis and shrinking towards x-axis by 1/2, that means I'm multiplying the y value by -1/2. And so that takes me to -6 -1/2. So 1, 2, 3, 4, 5, 6. And if this is 1, then -1/2 would be about here. So there's my new A prime. This is -1/2. This is a height of 1. Okay, B is at 0, 0. We move it left 5 units. That means changing my x coordinate, subtracting 5 to that. That leaves my y coordinate the same. Multiplying my y coordinate by -1/2 doesn't change that. So B prime is out here. And then C prime, well, C starts at 1, 1, goes left 5 units. So that means subtract 5 from my x coordinate. and then multiply my y coordinate by -1/2. So there's my new graph. It's been moved left, flipped, and actually shrunk, although since this is sort of a freehand sketch, you don't see the shrinking that well. But again, there's 3 special points. You keep track of where the 3 special points go by reading that off the formula. So finally, this one, what's the standard graph that we've manipulated? We start with y equals square root of x. And so we'll start by drawing in y equals square root of x. And this is a and this is b. So this is y equals square root of x. And we want to know, what does this graph, 3 times minus square root of x, mean? Well, we've multiplied inside the square root by -1. That means flip over y-axis. Multiply by 3 outside. So, we can do this without actually keeping track of the points, just by doing a couple of sketches. One is start by flipping over the x-axis, and we flip it over the x-axis, you get something like that. And the thing is, the second point is stretch it by a factor of 3. So we get b prime is flipped, and then if this is 1 unit, we make it 3 units up. And so this is the final position for b, so b double prime, and a doesn't move. So we get that graph. So you can, once you've done enough of these, you can sort of just see where it's going to go. Again, a is 0, 0. If we multiply inside by -1, that's multiplying my x coordinate by -1. That doesn't change it. Outside multiplying by 3 means multiplying the y coordinate by 3, and that doesn't change it. So a just stays where it is. B is the point 1, 1. Flipping it moves it to -1, 0. That's this part. And then multiplying, -1, 1, sorry. And then multiplying the y coordinate by 3 stretches it out to 3, and then you draw on the graph of the square root function. So this is y equals 3 square root of -x. And note that if we take negative numbers, then minus a negative number is a positive number, so you can't take the square root of that. So here's the graph of y equals square root of x. And it's got its 3 special points, a, b, and c. And here's a graph of another function. And this is also a graph of an absolute value, because it looks, the same thing. What are my 3 special points on this graph? Well, I'll call this b prime. A is 1 unit to the left of b, so we'll go 1 unit to the left, and we'll say that this is a prime. 1 unit to the right of b is the special point c, so we'll go 1 unit to the right and say that's c prime. So what kind of motions do I do that take a, b, and c on the graph of y equals absolute value x and give me a prime, b prime, c prime on the graph of this new function? Well, first off, b prime here is at the point -4, -3. So that means we've moved b left 4 units and down 3. So that gives me left and right and up and down. This y equals absolute value of x up here opens up. This one opens down. So we say, okay, opens down. That means we flipped it over the x-axis. That means we multiply. Oh, that's terrible handwriting. Multiply outside by -1. And the tricky thing is has it been rescaled? Has it been stretched at all? Well, to get from B to C here, you go 1 unit right and 1 unit up. But to get from B to C here, you go 1 unit right and you go 2 units down. So it's been multiplied outside because it's been stretched. C is now twice as far away from B vertically as it used to be. So multiply outside by 2. So what's our function? Well, it's going to be an absolute value. Left 4 units means that we add a 4 inside. Remember that moving left is positive +4. Moving right would be -4. So that's inside. Outside, we want to multiply by a factor of -2. It's supposed to be a vertical bar for my absolute values. And then down 3. And so there's our function. Formula for the function. So if you look at the graph, right, if you figure out where your special points have moved to, you can put together what were the motions that actually worked. So moved left 4, flipped over the x-axis, stretched by 2, and then, oops, down 3 would be -3. Okay. And so here's a graph of a function. What's the formula? Well, here you actually have to recognize what function this is. And so this particular shape, there's only one side of the graph, there's not another side. So we must have started with square root of x. We know what square root of x should look like. It should start here, this is A, and go up 1 unit, and that's B, and then it keeps going. So this is my A prime. 1 unit away from A is B, so 1 unit away from A up here is B prime. So what happened here? Well, we went down 2, right? A to A prime is down 2. Flipped over the y-axis, right? And again, to get from A 1 unit to the right up to B 1 unit to the right, that's a height of 1, right? The vertical distance between A and B is 1, but here the vertical distance between A and B is 1, 2, 3, right? And so it's been rescaled, it's been stretched. And it's been stretched vertically, so that's outside the function. So what's the formula going to be? Well, we start with inside the function, that's this, because that flipped it horizontally. And so that's going to be inside the function. So we have a -x inside of square root, and then multiplied by 3 outside, that stretches it, and then we moved it down 2 units. And so there's our formula. So again, if you know where the special points are in these graphs, and if you look at the graph that you get after it, right, this green graph here, then you can figure out what the various transformations were that gave you the new graph.